So this little video is to try to capture and help correct some misconceptions that students are having with writing the precipitation reactions and then balancing them. And I understand where the confusion is coming from, and I'm going to really try to make sure I'm very clear here. To write a balanced reaction, the first thing we have to do is write the reactants and the products. We don't try to balance until we have written good reactants and products. So I gave you the reactants, but I didn't give you their formulas. To come up with the formulas, you have to know their charges. So this is kind of a review of nomenclature. Sodium, if we look at a periodic table, we know it has a +1 charge. Sulfate has to be memorized. It's SO4 with a 2- charge. The Roman numeral 2 after the lead tells you that lead has a 2+ charge. And again, memorizing tells you that nitrate has an NO3 with a -1 charge. Now we're ready to write good formulas for these. To write a good formula, you have to make sure that you have as many positive charges as you have negative charges, because these compounds are always neutral. So you're going to have 2 of the sodiums with 1 of the sulfates. That will give you 2 positives and 2 negatives. It's a neutral compound, and that is soluble. Now we go to the lead nitrate. The lead has a 2+ charge and the nitrate a -1 charge, so I'm going to have 2 of the nitrates for every 1 of the leads. So I do Pb, and then I give myself 2 of the nitrates, and that's aqueous. Now we're ready to do the partner swap to figure out the products. And here is where the misconception comes in. Students see these subscripts, okay? The 2 for the sodium and the 2 for the nitrate. And they remember me saying you cannot change subscripts. Well, you can't change subscripts when you're balancing. Let's write that down. When balancing a chemical reaction, don't change subscripts. And we know that you can only use coefficients, but we're not balancing yet. There's no balancing happening at this point, okay? What we're doing is still writing the reactants. We wrote the reactants, now we're ready to write the products. So we're going to do a partner swap. That means the lead's going to get together with the sulfate. You always write the cation first. And the sodium is going to get together with the nitrate. All right, so we're going to take the sodium with the nitrate. Well, sodium has a +1 charge, and nitrate has a -1 charge. So the compound is NaNO3. I know that from the charges. And then we look at getting the lead together with the sulfate. Lead has a +2 charge. Sulfate has a -2 charge. So that again is a 1-to-1 ratio, PbSO4. Okay? I am using the charges to write the formulas. I'm not looking at a subscript of 2 and have a sense that I'm not allowed to change subscripts. That is only, and I'll put a box around it, when you're balancing, and I'm not balancing yet. Okay? The next thing we're going to do is decide what's soluble and what's insoluble using the solubility rules. According to the solubility rules, all 1A metals are soluble. So this is going to be a soluble ionic compound, so I put AQ after it. Sulfates are generally soluble, but there's a few exceptions, and lead is one of them. So that tells me that this is the solid, this is the precipitate. Now I'm ready to balance. When you balance, we don't change subscripts. We only, and we'll put this on there, only use coefficients. Okay? And that's where students were getting confused. We weren't up to this point balancing. Now we're ready to. All right, so we have 2 sodiums on the left-hand side. We need 2 sodiums on the right-hand side. So I put a coefficient of 2 there. And we have 2 nitrates. There's 2 nitrates. There's 1 lead, 1 sulfate, 1 sulfate, and now it is balanced. So that is the what we would call the molecular equation. It's a misnomer, but that is when we write them together like that, that's what we call it. In your recitation assignment, I say follow my example to write a complete ionic equation. And so let's go ahead and just do that. The complete ionic equation is to break these apart into their ions. What I have here is 2 sodium ions and a sulfate ion in this ionic compound, and this is how you represent that. I have 2 sodium ions and I have 1 sulfate ion. Notice how the subscript became the coefficient, because when it breaks apart into ions, each of those are floating around independently of each other. They don't stay hooked together. The lead, Pb, that doesn't look like a P to me. Let me put the P in front of it. Pb 2+, and there are 2 nitrate ions floating around. On the right-hand side, we have 2 of the sodium ions floating around. We have 2, the 2 goes to the nitrate as well, 2 of the nitrate ions floating around. Since this is a solid, we don't break it apart. They're not separate from each other. The solid is sulfate, lead sulfate, and an S. So that is the complete ionic equation. Then we cancel spectator ions. Spectator ions are appearing exactly the same on both sides, and what remains is your net ionic equation. All right, so I'm very hopeful that I have helped you understand what I mean by don't change the subscripts. That's not until you're ready to do the balancing step. Of course you have to change subscripts as you write good formulas for your products, because good formulas are neutral compounds, and the neutral compounds are written with the lowest whole number ratio of ions. So go work on that recitation assignment. Keep posting in Piazza when you have questions.